All right, so today we're going to be working on section P.2, part A. There is a part B, but we're not actually going to do it. Solving linear inequalities. Now, inequalities are these symbols right here. Less than or equal to, greater than or equal to, or not equal to. Now, the not equal to one, we're not really going to use, but these other four on top, we are. Okay, so less than or equal to, greater than or equal to. We're going to be solving inequalities, just like what you did yesterday, solving equations. Same idea, but the only difference is we're going to be graphing their solutions. Now, don't worry, the graphs we're going to be doing are on number lines. They're pretty simple, okay? I do want to remind you guys, though, of something here. Um, whenever you see less than, okay, usually it's going to be like an open circle when you graph it going to the left, okay? Usually there are some uh, things you can do that might change the direction. Less than or equal to will kind of look the same way, but it's going to be a solid circle going to the left. Greater than, well, that's going to be an empty circle going to the right. Greater than or equal to, solid circle going to the right. Those are the four that you kind of have to know. Notice if it says equal to, the circle is colored in. Okay? If it doesn't say or equal to, the circle is empty. Okay? And then the not equal to, I'll show it to you, but we're not going to use it. Okay? But not equal to goes like this. Not equal to means it can be anything except for this one thing. So it's like a little empty circle, but then it accounts for everything in both directions. But we won't use this one. Okay, we're not going to use this bottom one. It's not necessary. But we are going to use the top four. Okay, now right under that, I said importance. Okay, something that's very important. I'm sure you guys already kind of know this. But if you add and subtract in inequalities, nothing special happens. You're just kind of adding and subtracting. But when you multiply or divide, some things can happen that are kind of weird, especially when the number you're multiplying and dividing by is negative. Okay, so I'm going to write down a really quick definition. It's actually part of your homework, just so you know, this definition I'm about to write down. Even though it's not an example, I am going to ask you to write down the definition for part of your homework. And it basically says the following. When you multiply or divide both sides of an inequality, so when you multiply or divide both sides of an inequality by a negative number, okay, then you must flip the inequality, or flip the direction. Let me put flip the direction of the inequality. So if the arrow was originally pointing like to the left and you divide both sides, say by -2, then you should switch it so now it's pointing to the right. Or if it was originally pointing to the right, then switch it to point to the left. But don't change it. If it's a greater than or equal to, make sure that when you flip it, it still has the or equal to part, okay? It's never going to become like less than, then you flip it, now it's like greater than or equal to, right? It's never going to gain anything. It's just going to either be an arrow pointing left that gets switched to the right, or an arrow that points right that gets switched to the left, okay? This only happens when you multiply or divide both sides by a negative number. Usually multiplication is seldom, like 85% of the time you're going to be dividing to do these problems, okay? But there's a small percentage, right? 15% of the time you may have to multiply both sides by a negative number, but it really is more common to divide, okay? So like I said, on your homework, the very first question in your homework says, when do you switch the direction of the sign when solving an inequality problem? That's number one on your homework. That's what you're writing, the thing in green. Okay? So I already gave you that answer. but it's okay. This is a definition that's important for you guys. Now, we are going to do 4 examples because you have 8 problems. Well, 8 plus the one I just gave you. There's actually 9 problems on your homework. We already did one, the green definition, okay? We're going to do 4 more, and then after those 4 more, I'll give you guys your homework. You'll be 55% of the way done. You just got to do the other 45%, okay? So we're actually doing more than half. We're doing a little bit more than half. So all of these problems that we're about to do, they're all going to say solve the inequality. 3 of the 4 will say and graph, and the last one will say do not graph. Okay, so we're going to graph 3 of them. 1 of them we won't. So here we go. We're going to start off. Remember what I told you? We start off with easy ones, start moving a little bit harder, right? So the first one, -3 is greater than or equal to -8m plus 5m. You can see on the right side, I have variables on the same side, so I can combine them. So -8m plus 5m is -3m. So this is -3 greater than or equal to -3m. Now, to solve for m, I need to get rid of that -3 in front of it. So I'm just going to divide, right? I'm going to divide both sides by -3. So my answer is 1. But since I divided both sides by a negative number, that arrow, which is pointing to the right here, okay, this arrow right here, the one I'm circling, okay, the one that's pointing to the right is going to now switch direction, okay? And then I'm going to write the variable that's left over, and this is my answer, okay? Now, just a little word of advice, okay, a little side note really quick. So I'll put it right here to the side. If it looks like this, let's say if it's like x greater than 3, I'm going to put follow the arrow. So when you're going to graph it, if it said like x greater than 3, see how the arrow is pointing to the right side? So follow the arrow when you're graphing. Draw it going to the right, okay? But if it's backwards like this, let's say it says 3 greater than x. Notice how x is on the right side of the inequality, not the left side of the inequality. When it's on the right side, you're going to go the opposite way. So this arrow is pointing right, so you're going to have to go left. Okay? So I'm going to put opposite direction. Just a little hint. So when your variable, when you solve it, if your variable is on the left side of the inequality, just follow the arrow. If the arrow is pointing right, go right. If it's pointing left, go left. Okay? If your variable is on the other side, on the right side of the inequality, then you have to go the opposite direction. If it's pointing left, you're going to go right. If it's going right, you're going to go left. Okay? Opposite direction if it's on the opposite side. So here we go. Let's graph the one that we just did. Now to graph these, we're just doing a number line. We're not doing a coordinate plane. Okay? And I'm going to graph this kind of like the lazy way. I always tell people it's like a lazy number line. I get my answer of 1. I'm going to put it in the middle. And then I'll put like a 2 to the right. I'll put a 0 to the left. That's it. That's all I need. It gives you some kind of idea that I know how to number a number line. Okay? So 0, 1, 2. Now, since it says less than or equal to, I'm supposed to put a solid dot right there. So solid dot on 1. I always draw my number lines above it. I always draw my graphs above the number line. So you're going to see minus floating. I just prefer it. If you want to draw it on it, it's fine. Below it is fine. I don't care. Okay, mine are always above it. And then since my m is on the right side of the inequality, that means that arrow is pointing the wrong way. So right now it's telling me draw it to the left. So I'm actually going to go right. And I can always check it because this tells me that 2 is an answer, right? This picture, it says 2 is an answer. Is it true that 1 is less than or equal to 2? Yeah, 1 is less than 2, right? So that makes sense that I'm drawing it this way. If I would have drawn the arrow this way, that means 0 should make sense. Is it true that 1 is less than or equal to 0? No, that's false. So notice it's pointing the wrong way when the variable is on the right side. If it's on the left side, it's pointing the correct way. Okay? So be mindful of that. Okay? Don't always, I know there's some teachers I've heard, some of my students in middle school told me, like, they just used to say, follow the arrow. And I'm like, but what if you solved it and the variable's on the other side? They're like, we just followed the arrow. I'm like, did you get a lot of stuff wrong? They're like, yeah. I'm like, because that's not correct. You don't always follow the arrow. Here's number 5 from your homework. Okay? You'll notice I kind of switched from example 1, example 2, because I know one person, well, actually, there's 2 people in one of the classes, were kind of getting confused because they thought that example 1, 2, 3, 4 were literally 1, 2, 3, 4, 5. So they kind of had to redo the write up on their assignment. But right here, number 5 is actually number 5. We're going to solve the inequality and graph. Okay, now notice it's getting a little bit more busy. We're going to distribute. Okay, so let's go ahead and do that. So 6 times 1 is 6, plus 6 times 7, that's 42x, plus 6x is less than negative 90. Now I'm going to notice on the left side, I have common terms, right? Like terms, 42x plus 6x, that's 48x. So I'm going to write 6 plus 48x less than negative 90. Now I want to get the variable by itself. I see this 6 is just kind of hanging out by itself. So let's move the 6 to the right side where the negative 90 is. Okay, so that plus 6 is going to go over there. Okay, so I'm going to write 48x less than negative 96. Because remember, the 6 becomes a negative, right?
I think you accidentally put 48 instead of 42.
Oh, well, I added 42x plus 6x.
Oh,
Yeah,
I
yeah.
didn't see that.
Yeah, right now when you said that, I'm like, yeah, I did. Why did I do that? And then I realized I did add it. Thank you though. But yeah, I did add it together. So yeah, and then when I move the 6 over to the right side, it becomes negative. So negative 90 minus 6 is negative 96. Now I'm just going to divide both sides by 48. And I'm going to tell you something that one time a student asked me, which makes sense. I divide by 48 on both sides. I get x is less than negative 2. And I had a student a couple years back, whenever these types of problems would show up, they say, like, is that right? Like, you forgot to flip the sign. And I said, what do you mean? They say, well, yeah, you divided a negative number. And I said, oh, no, I did. I divided a negative number. I said, but the rule says when you divide both sides by a negative number. I said, did I divide both sides by a negative number? They're like, no. I said, then you don't flip it. You can divide negatives. That's okay. Nothing happens to the sign. It's when you divide both sides by a negative number or multiply both sides by a negative number. So yeah, sometimes people get a little confused when they see negatives here. They think they always got to flip it. Like, no, look at the number on the bottom. Okay. So here's my answer. Let's go ahead and graph it. Okay. So again, I'm going to do a real quick lazy number line here. So here's negative 2, negative 1, negative 3. Okay, so at this point, I'm going to create my circle. Now, this is a less than. So less than means that it's only going to be a circle that's not covered, right? It's going to be an empty circle. So I'm going to put a circle right there. Okay, and then since x is on the left side, I'm going to follow what the arrow says. I'm going to go left. Okay, this little inequality right here, x less than negative 2, it's pointing left. So I'm going to go left as well, because my variable is on the left-hand side. Okay? Are we good with that one? Pretty straightforward. Oh, hold on. If you want, what do you want to leave it here, or you just want to hang out here? Okay, yeah. Take a seat. I'm almost done. All right, so let's do this next one. I was actually going to let you guys work on this one on your own. I'm going to give you about a minute and a half. Okay? Try doing this one. Remember, you are going to distribute, and then we'll do the last example, and then I'll give you guys your homework. So go ahead and try that out. I'm going to actually pause the recording so that there's not like 2 minutes of dead time. So let me pause it. All right, so gave you guys a little bit of time to try it out. Let's let's go ahead and see what the solution is. So I'm going to distribute 8 times a, that's 8a, plus 8 times 6, that's 48, greater than or equal to 34, minus 6a. So you should have gotten that once you distribute it. Then you combine like terms. Notice 8a and negative 6a are on different sides of the inequality. So I'm going to have to get this negative 6a and move it to the left. It's the smaller of the two. I always like moving the smaller of the two. So I'm going to move this negative 6a over to that side. So it's going to become positive. So 8a plus 6a, that's 14a plus 48, greater than or equal to 34. And let me just move the 48 over to the right side. Okay. So 48 goes over to the right. It's positive right now. When it moves over, it becomes negative. So I get 14a greater than or equal to negative 14. And now I'm going to divide both sides by 14. So a is greater than or equal to negative 1. I'll graph it, and then we'll move on to the last problem. So here we go. The graph for this one should look something like this. By the way, your homework will have all the graphs there for you. You're not going to have to draw them. They'll be there already. But if you want to draw your own, go ahead. But there's mine. This says greater than or equal to. So my circle is going to be solid at negative 1. Okay, so solid circle at negative 1. Greater than or equal to, since my a is on the left side, my variable is on the left side, that means I can follow the arrow. So I'm just going to go to the right, and I'm done. Okay, so there you go. That's the solution. Go ahead and start copying that one down. We're not going to graph this one, but we are definitely going to solve it. It's one of the, I don't want to say it's the most difficult problem. It's just busy. Most of these problems are just busy, right? I don't want to say they're difficult to do. They're a little distracting because there's a lot of parentheses and all that stuff. So sometimes that stuff scares people. They think, oh, it has to be difficult because it's more than 4 numbers, right? But not really true. A lot of times it's just pay attention to what you're doing, you'll be fine, right? Focus, you'll be okay. So here we go. Notice we have 2 sets of parentheses. We're going to have to distribute twice, okay? So distributing here, distributing here. So let's go ahead and do that. So negative 6 times negative 4, that's 24. Negative 6 times 5x is negative 30x. Then I have a plus 4 that's just hanging out by itself. Then I'll distribute on the right side. 2 times 2, that's 4. 2 times negative 3x is negative 6x. Now, the smaller of the two, well, actually, before I move the variables, let's combine 24 and 4. So 24 plus 4, that's 28. So let me rewrite that. 28 minus 30x is less than 4 minus 6x. All right. Now, look at your variables. Negative 30x, negative 6x. The smaller of the two is the negative 30x. Remember, the number, when a number is negative, the bigger it appears, the smaller it actually is. Just think of it as money, right? If you owe me 30 bucks or you owe me $6, well, you owe me more if it's 30 than 6, right? So negative 30 is a smaller number in terms of value. So we're going to move this negative 30 over. That's going to make it positive. So I get 28 less than 4. Negative 6x plus 30 is a positive 24x. Let's move that 4 to the left-hand side. So it's going to become negative. So 28 minus 4, that's 24. Whoops, sorry, less than 24x. And my last step is going to be just to divide. So divide by 24. So 1 is less than x. If I were to graph this, which I'm not, but if I were to graph it, I'd have to go the opposite way that the arrow is pointing because my variable is on the right side of it, not the left side of it. So I would be graphing it to the right, not to the left. Okay? So I'm going to give you guys your homework. You can start working on it. I already gave you 5 of them out of the 9, or you can start working on the new ones. It's up to you.